Hi everyone, welcome back. In this video, we will learn about density. Our learning goal is to calculate the density of a substance and use the density to calculate the mass or volume of a substance. And the formula we will be using is density is equal to mass of a substance over volume of a substance. And we will always be referencing to the density of water. Water's density is 1 gram per milliliter. And anything that has a higher number or higher density than water will sink, just like aluminum, which has a density of 2.7, 0 grams per milliliter, or lead, which has a density of 11.3 grams per milliliter. And anything that has a less density compared to water, such as ice or a cork, will float. Here you'll see some densities of some common substances. For example, as you can see, that a lot of the metals, like copper and silver, lead, they all have densities that are pretty high, and so they would sink in water. You can see here gasoline and ethanol and olive oil all have densities less than water, so they would float, especially because they're not going to mix. Well, ethanol would mix with water, but olive oil doesn't like water because it's pretty hydrophobic, and so it would float. And you'll notice here that some densities of gases, but just note that the units are different, grams per liter as opposed to grams per milliliter. And also the temperature that we record the density also impacts that value. So solids and liquids, these measurements were done at 25 degrees Celsius, whereas gases are 0 degrees Celsius. So density allows us to compare the mass of an object to its volume. So once again, density is mass of a substance over volume of a substance. And for density of solids and liquids, we typically use units of grams per cubic centimeter or grams per milliliter. And if you're reporting the density of a gas, then that's usually grams per liter. And just remember from a previous video that 1 milliliter is the same as 1 cubic centimeter. Now, how do we measure the density of a solid? Basically, we can take the mass of the solid, divide it by its volume. And sometimes the solid may not have a regular shape. So for example, you can determine the volume of a cube by taking the sides cube that. But if your solid doesn't have a regular shape, a geometrical shape that you can easily determine the volume, then you're going to do an experiment called volume displacement. And just so you can see here, first we took this metal object here, we weighed it on our mass balance, and then we had a graduated cylinder filled with an initial volume of water of 35.5 milliliters. And then we added the metal object into it, and you can see that the water level rises. Now, we didn't add more water to make the water level rise. Rather, it was the object's volume that increased the reading of the water in this graduated cylinder. And so the final volume is 45 milliliters. And so the difference in these volumes is what gives you the volume of the object. Now, I just want to note here, this is a water solution. They just added blue dye so that you can see the difference easier in the figure. And so as you can see here, to determine the displaced volume, we submerge the solid in water so that it displaces water that's equal to its own volume. So to determine that, you would do final volume minus initial volume to get the volume of the object. So this is VF minus VI. So whenever you see VF, that's final volume. And VI is equal to initial volume. So VF minus VI will give us the volume of the object that we are measuring by volume displacement. And so once you have that measurement, you take the mass of the object divided by the volume and you get the density, 7.2 grams per cubic centimeter. Now go ahead and pause the video, try the study check on your own, and come back and check your answer with me. All right, what is the density of a 48-gram sample of a metal if the level of water in the graduated cylinder rises from 25 degrees or 25 milliliters to 33 milliliters after the metal is added? All right, so as you can see here, a lot of times when I do word problems, I like to draw things out. So I'll sometimes draw a graduated cylinder on my paper and then record like, okay, the initial water volume was 25 degrees or 25 milliliters. And then the final water volume was 33 milliliters. And I'll add an object so that I have this nice visual. So our given data is VI is equal to 25 milliliters and VF is equal to 33 milliliters. And so we are also given that the mass of the metal, we don't know what the metal is 48 grams, and we need to find the density of the metal. And that's what we're trying to find. So I'm going to go ahead and write that formula. So mass of metal over the volume of the metal. And we just learned that with volume displacement, we can find the volume of an object. In this case, it's a metal object by taking VF minus V initial. And so that would be 33 milliliters minus 25 milliliters is equal to 8 milliliters. And then once we have that information, we can plug it into our density formula because we were given the mass, 48 grams over 8 milliliters is equal to 6 grams per milliliter. So remember, units for density are either grams per milliliter or grams per cubic centimeter. And so right now I have it in grams per milliliter, but just remember that 1 milliliter is equal to 1 cubic centimeter. And so basically 6 grams per milliliter is the same thing as 6 grams per cubic centimeter. And these are the units we use for densities of solids and densities of liquids. And so here's a step-by-step guide to using density. So if the volume and the density of the sample are known, the mass in grams of the sample can be calculated by using density as a conversion factor. And so first, always state the given and the needed quantities. Step 2, you always write a plan to calculate the needed quantity. Step 3, you write the equalities and their conversion factors, including density. And step 4, you set up the problem to calculate the needed quantity. So we won't always be calculating density. We may use density once again as a conversion factor. So in the previous problem, we determined that the metal object's density was 6 grams per milliliter. basically what that's saying is that it's 6 grams per 1 milliliter, or 1 milliliter is equal to 6 grams. It's a relationship between the mass of the object and the volume of the object. So we can take any density value and use it as a conversion factor. And same thing, if you switch this 1 milliliter to cubic centimeter, because that's the same, 1 milliliter is equal to 1 cubic centimeter, you can use that conversion factor as well. So let's do an example together. John took 2 teaspoons of cough syrup. If the syrup had a density of 1.20 grams per milliliter, and there is 5 milliliters in 1 teaspoon, what was the mass in grams of cough syrup? All right, so step 1, always write down your given and need. So we are given that the volume is equal of the cough syrup is 2 teaspoons. We're also provided the density, so that's the syrup that was taken. We're also provided the density of the syrup is 1.2 grams per milliliter. And we're given an equality within the problem. There's 5 milliliters in 1 teaspoon. So let's write that. 5 milliliters is equal to 1 teaspoon. And we are asked to find the mass of the cough syrup. So we need the mass of the cough syrup. And so step 2 is just to write everything that we know in kind of a plan of attack. So I'm going to write some notes down of some things that we do know. So for example, I see that equality of 5 milliliters. I'm going to go ahead and write conversion factors because I know I'm probably going to need that in a little bit. I also know that density is a conversion factor, so I'm going to write that as conversion factors as well. 1.20 grams per 1 milliliter, or 1 milliliter over 1.20 grams, and that's for the density of the syrup. I'm also provided, the formula. Density is equal to mass over volume. And I recognize, like mass is part of the density formula. So I may be able to use this formula to figure out mass in the end. But let's go ahead and start our dimensional analysis because we like to use conversion factors to cancel out units. So we may not always need to use the actual formula because the dimensional analysis will lead us to solving for our mass in grams. And whenever you're given multiple pieces of data, always start with the data that's a single unit. So 2 teaspoons. Whereas we can see here that density has 2 different units. And this equality of milliliters to teaspoons is also 2 different units. So when we start our dimensional analysis, start with the given value that is a single unit. And it will guide our way. So draw your ladder here. Remember, our point is to cancel out units. Eventually we want to be in grams, but if I want to cancel out teaspoons, which conversion factor would you want to use over here? Excellent. You'd want to use that first conversion factor, which has 5 milliliters on top here and 1 teaspoon down below. So teaspoons of the cough syrup cancel out, and now we're in milliliters of the syrup. But we don't want to just be in milliliters, we want to find the mass. And so it looks like density will help me convert from the volume in milliliters to mass in grams. And it seems like the first one is the way to go here because that will allow me to cancel out milliliters. And we can see that milliliters cancels out. And so now this is going to give me the grams of cough syrup. And so when I plug this into my calculator, and do this with me if you haven't done so already, I'm going to say 2 times 5 times 1.2 gives me 12 grams. Exactly. So 12 grams of the cough syrup. And two significant figures works just fine because everything's multiplication here, and 2 is the least significant figures. Remember, 1 is considered an exact number. So our final answer of 12 grams of syrup works out. And so once again, you didn't necessarily need to use the formula and rearrange. You can use conversion factors to help arrive to the answer because density in of itself is a conversion factor. Now, if some of you feel more comfortable doing algebra when there are equations available like the density formula, that is totally fine. I'm going to stick with using dimensional analysis primarily because when you learn about chemical reactions and stoichiometry in a later video, you will be using the same technique of dimensional analysis to solve those problems confidently. Now, since many students who are taking this class may be going into the medical field, you may be working with something called specific gravity. And specific gravity, which is abbreviated SPGR at times, or sometimes I'll just also abbreviate it as S capital G, is the relationship between the density of a substance and the density of water. It is calculated by dividing the density of the sample by the density of water, which is 1 gram per milliliter at 4 degrees Celsius. And because you're dividing density by density, it ends up being a unitless quantity. And from a chemist's perspective, knowing the specific gravity of a substance will help me know if a substance will float or sink in water if we're discussing something that's a solid object. But also from a medical point of view, many times specific gravity is used when testing a patient's urine. And the urine specific gravity measures the concentration of particles in urine and the density of urine compared to the density of water. It's an easy and a convenient way to gauge a patient's hydration status, as well as the functional ability of their kidneys. So like I said, many of you who may be going into the medical field may be working with specific gravity for different patients. And so simply the formula is specific gravity is density of the sample over density of water. So go ahead, let's do a study check, pause the video, try this out on your own first, and then come back and check your work with me. All right, an unknown liquid has a density of 1.32 grams per milliliter. What is the volume in milliliters of a 14.7 gram sample of the liquid? And what is the specific gravity of the unknown liquid? All right, once again, step 1, let's always write down what we know. So we are given that the density of our unknown, so I'm going to just write density of U as our unknown, is equal to 1.32 grams per milliliter. And I'm also given the mass of the unknown liquid, which is 14.7 grams. And I'm asked 2 questions. First, I need to find the volume of the unknown, and I'm also asked to find the specific gravity as well. Once again, step 2, write down everything you know in terms of conversion factors, maybe formulas you like to use, so that we have a plan of attack for this problem. So I know that density is a conversion factor, so I'm going to write it as a conversion factor. I like to write both conversion factors so I can make a decision when I start my dimensional analysis. And once again, I'm going to use dimensional analysis as opposed to just using the density formula. But if you use the density formula, that is totally okay, as long as you get the right answer. All right, so I'm going to start with the mass because it's a given measurement that's only a single unit, whereas the density was 2 units, grams and milliliters. And so when I see here, I have the mass of the unknown. I want to find the volume. I know density will get me from mass to volume. So I'm going to use which conversion factor? The second one. Excellent. So let's go ahead and put that in here. 1 milliliter over 1.32 grams. And I'm going to erase this and plug that into my calculator. 14.7 divided by 1.32. And I get 11.136 milliliters, because remember, grams cancels out. And it asks for the units in milliliters. Also, because this is division, we report to the fewest significant figures. Both are 3. So I'm going to round my answer to 11.1 milliliters for the volume of this unknown liquid. I'm also asked for specific gravity. So I'm going to write the formula. So specific gravity is equal to the density of the sample. So in this case, the unknown liquid over the density of water. And we will always assume that the density of water is equal to 1.0 grams per milliliter. And in this case, the density of the sample is 1.32 grams per milliliter. And grams per milliliter cancel out. 1.32 divided by 1 is equal to 1.32. Remember that specific gravity is a unitless number, unitless measurement. And what this tells me is that this number is greater than the density of water. So if this liquid doesn't mix with water, then it will sink. All right, in the past several videos, we've gone over quite a few ways that we can make measurements in chemistry. And this is a concept map relating some of these bigger topics and learning objectives. Remember, we learned how to utilize prefixes that helps us change the size of the different metric units. And in terms of measurements, we more often measure length, mass, volume, and temperature and time in chemistry. We also learned about equalities and how we can use equalities to write conversion factors, which are crucial for problem solving through dimensional analysis. And once we solve problems, we also learn how to report to the correct number of significant figures and the proper way for rounding off answers, and whether or not we need to add zeros to indicate the order of magnitude of that final measurement value. And finally, we've just covered density and specific gravity. Thank you for watching, and as always, email me with any questions.